The next stage in creating the player is to make a script to control his movement. Select the player and add a new script to him called Player Movement. Empty the script. Let's start out as usual with the public variables. We need an audio clip to store the sound of the player shouting. We'll call the variable shouting clip. We're going to use a lerp function for changing the direction of the player. As such, we will need a smoothing value. When we set the speed parameter of the player's animator, we want to apply damping. We'll store the damping time as a public float. We will also need a couple of private variables to store references. Firstly, to the animator component. And secondly, a reference to the #ID script. Now we can use the awake function to allocate these references. We are also going to use the awake function to set the weight of the shouting layer in our animator controller. The weight of a layer is its effectiveness, so if set to a value of 1, this layer's animations have the potential to completely override any layers beneath it, such as the base layer. Since we're using an avatar mask, and most of the time the shouting layer will be in an empty state, we can set the layer weight of this to 1 without it affecting the base layer's animations. This function takes two arguments. The first is an integer, an index of the layer. For example, the base layer is 0 and the shouting layer is 1. And the second argument is its effectiveness, a value of 1 as we stated earlier. The player is a physics object, so we'll be dealing with his movement in the fixed update function. Add this now. We're going to start by caching the inputs that we get from the user. This way, we can use them when we need them without having to call any input functions again. Now that we have our input, let's make a function to use that information to manage the movement. We will call it movement management, and it needs to take in parameters of the input variables that we've just cached. First thing we can do here is set the sneaking animator parameter by using the sneaking variable that we're taking as an argument in this function. We can use a reference to the #ID script to determine the parameter we're setting. The style of movement we're going to have for the player is one in which the player's direction is determined by the axis input. The player turns to that direction and runs forward. We're going to have the rotation of the player changing smoothly but quickly, in order to give the controls a responsive feel. To achieve this, first we need to determine if there is any directional input. To make the player rotate to the direction defined by the directional inputs, we'll make a function to handle it. This function will need the horizontal and vertical variables in order to determine a target rotation. If we imagine the new direction we want the player to face as a vector, it can be represented by an amount in the x direction of the horizontal input and an amount in the z direction of the vertical input. So if both horizontal and vertical are 1, that is, if up and right are being pressed, then the player should head in the positive x and z directions. We will store this intended direction as a vector 3. Now we need to convert this vector to a quaternion so that we can adjust the player's rotation towards this. A quaternion is a way of storing a rotation. This is a more advanced topic, but we need this to assign rotation back to our character. Unity has a built-in function that simplifies this process for us called lookRotation. LookRotation is a static function of the quaternion class. It takes two arguments. Firstly, the vector representing the direction you want to convert to a quaternion, and secondly, a vector representing the up direction. We want to smooth the rotation of the player as he turns. To do so, we're going to use lerp to get a new rotation that is a slight change from the current rotation in the direction of the target rotation. We will use our current rigid body.rotation as the direction to go from, and the target rotation from our key input as the direction to lerp towards, with our turn smoothing variable to control how long this takes over time. We can then set the rigid body's rotation to this new rotation using rigidbody.moveRotation. With the rotating function finished, we can return to the movement management function to put a call to it. Whilst we're still within this if statement, we know that we're receiving input, so we know the player should be moving. As such, we can set the speed parameter of the animator. We're going to set it to 5.5, as this is approximately the speed of the animation as determined by the blend tree. We're going to apply damping to the parameter as we set it. This will assure transitions are smooth whilst remaining responsive. If, however, we're not receiving any input, then we want to set the speed to 0. With the movement management function finished, we can put a call to it in our fixed update function. We have still to add the audio for our player, both his footsteps and the sound of him shouting. For this, we'll make an audio management function. We only want the footsteps audio clip to play whilst in the locomotion state, so we should first of all check if that's the state that the player is currently in. We can use the name hash since we have the appropriate state stored in our hashIDs script. Here we're using getCurrentAnimatorStateInfo with a value of 0 to refer to the state that we're in the base layer. We also only want to play if the clip is not already playing. However, when we are no longer in the locomotion state, we don't want the clip to continue on until it is finished, so we will stop it here. Because we're using our audio source component to manage the footsteps of the player, we will be using the playClipAtPoint function to manage the shouting. This is because the audio source will already be playing back the footsteps, and we don't want to replace it with the shouting. The condition for playing back the shouting clip is that shout is true. playClipAtPoint takes two arguments, an audio clip and a vector3 for position. It creates a new object in the world at the specified position and plays a sound there. This object then self-destructs so that it's no longer left in the scene. Now our audio management function is complete. In order to call this function, however, we need to place it in the update function. We will place this in our script below the fixed update function. We do not need to put update here, but it makes the flow of the script slightly easier to understand when reading it. The update function could be anywhere, it's purely a matter of preference. The first thing we want to do is cache the input of the attract button. Next, we're going to pass this input as a parameter to the animator controller so that the player performs the correct animation. Finally, we will pass the shout bool into the audio management function as we call it, so that this is the triggering input that causes our shout to play. Now we can save the script and return to the editor. The player is now ready to test, but before we do, let's tidy up our scripts folder one more time. We're going to add a new subfolder to the scripts folder called Player. Select the scripts folder in the project panel and go to Create, Folder. Call this Player. Select the Assets folder and then drag in player movement into this player folder. Don't forget to save the scene and the project now. Then we're ready to test the player. Let's zoom out a little from him in the scene view and rotate our view around to mimic the position of the camera that we'll place in later. Before we test, we'll need to assign the shouting audio clip to our player movement script, so select the player character, car Ethan, again in the hierarchy. You'll see that the player movement script has none audio clip next to shouting clip, so in the audio folder, drag player attract attention to this variable. Now let's playtest. Press play at the top of the interface. You should now be able to drive your character around, observing him in the scene panel. You can use the arrow keys or W, A, S and D on the keyboard. Remember, you can use left shift to sneak and you can press X to shout.
Hey!
As we're playtesting, we notice that the sneaking animation seems rather slow, but we can adjust this very easily. Press the play button to stop testing, and return to the animator window. Go to the base layer, and select the sneak state. In the inspector, set the speed to something greater. Let's try 1.7. Now let's press play again and see the change. Now if we move and hold Shift, our sneaking is a little faster. These are the kind of tweaks that you can make as you test your game to improve it over time. In the next assignment, we'll make a script to handle the player's health.